Good day, everyone. I am Chaeeun from KAIST, one of the authors of this paper. In this presentation, I'll introduce our research, Viewer2Explorer, and share our approach to enhancing user experiences in 360 video virtual exhibitions. With the rise of COVID-19 pandemic, virtual museum experiences have become increasingly popular, allowing people to explore exhibitions from the comfort of their homes. If you are a museum goer, chances are you've tried or heard about virtual museum tours with this kind of panoramic images. These experiences provide direct and autonomous navigation in the virtual space, offering visitors a taste of museum without leaving their home. Similarly, museums have embraced another option for virtual visitors, which is a virtual tour with 360-degree videos sharing on web platforms like YouTube. But unlike panoramic images, which offer immersive experiences akin to walking and full body control in the virtual world, as you know, 360 videos offer relatively limited interaction, like head movement or viewpoint. Additionally, due to the nature of video media, viewers typically follow a predefined narrative in chronological order rather than actively exploring. So in other words, panoramic images can give users full controllability and feel like they are really in there. But 360 videos limit users' movement and make them feel more like being guided around by riding on someone's back. In our research, we focused on enhancing viewers' ability to interact with 360 video, aiming to give them more control over spatial navigation. Unlike traditional methods, like the name of the research, our goal was making viewers to explore in 360 virtual exhibition. So how did we achieve this? Initially, we observed that conventional timeline interfaces still dominate viewing experiences on desktop environment. These interfaces have been originally designed efficient time point browsing in video. So we thought this type of time-based interface should be changed into spatial-based interface to support spatial navigation in 360 video content. Consequently, rather than focusing on the temporal interaction, we designed a map-based video interface for spatial interaction. With this interface, we thought that viewers can understand the spatial layout of the exhibition space within the video and engage in active exploration with their intention, not just borrow someone's view. To achieve this, we devised a simple yet effective concept. We captured the entire exhibition space with 360-degree cameras and mapping the video timeline to the exhibition map for intuitive spatial navigation. So with this method, viewers can move to a specific location by clicking on a spot on the map interface, similar to navigating to a specific time point by clicking on a timeline in conventional video interfaces. It means that viewers are actually moving between time points, but they feel as if they are navigating spatially rather than temporally. For detailed interface design, we established design considerations based on various existing interfaces and approaches requiring spatial navigation. Then we designed the components and detailed interaction of Viewer2Explorer. As a result, we designed the map-based interface includes graphical elements such as passes, indicators, field of view, and coins. We thought these elements can help viewers to understand overall exhibition layouts and each exhibit's locations. We expect that these visual cues may help viewers recall visited passes and motivate them to explore the entire exhibition. In this kind of map structure, viewers always encounter crossroads. Therefore, in such cases, we designed the interface to allow users to select the direction to move when facing crossroads, and eventually make them to feel in control of the navigation. Also, we designed Viewer2Explorer's video control method same as existing timeline interfaces, but a different features. This adjustment aimed to minimize any awkwardness resulting from replacing temporal navigation to spatial navigation. For example, we replaced the traditional faster and slow controls with acceleration and deceleration features. Also, we replaced the skip functions to skim through the space, like walking faster in a real exhibition space. So from this slight modification, we intend that this change metaphorically represents the footsteps of visitors. After developing the prototype, we conducted a user study with 24 participants divided into two groups. One is the T group using the traditional timeline interface, and the other one is the T plus M group using Viewer2Explorer. All participants have been instructed to explore the same 360 video exhibition at their own pace using their each assigned interface. The study included survey questions on spatial awareness, autonomy, museum experience, and interface usability, along with NASA TLX for measuring task load of the experience. Survey results showed that Viewer2Explorer significantly improved participants' spatial awareness and autonomy, leading to increased engagement. Participants using the map interface showed higher scores for sense of reality, self-orientation, and imageability, indicating better awareness of their location and direction. It seems that the map interface supports navigation easier and enhanced their sense of presence. They could easily find their ways or revisit areas by understanding the overall layout of the exhibition space. Also, those who used the map interface reported higher perceived interactivity and agency, feeling more autonomous in their viewing experience compared to those using only timeline interface, who tended to be more passive viewer. Despite being aware they were watching a pre-recorded video, participants who used the map interface expressed enjoyment in freely exploring the exhibition with their own intentions, similar to navigating a virtual game environment as a game character. Participants who used the map interface also reported higher satisfaction, engagement, and understanding of the content. It seems that they perceived the exhibition as their own experience, deriving satisfaction from autonomous navigation. In further analysis, we found that participants interacted differently with the video exhibition based on how they control it. Those who use only timeline interface mainly used play and pause to stay immersed, while map interface uses actively manipulate various functions, especially speeding up the video to direct the videographer's footstep. Essentially, participants in the T condition enjoyed the immersive experience of following the videographer's move, while those in T plus M enjoyed actively guiding the videographer's movements. Based on user study results, we discussed Viewer2Explorer's impact on three key features, which is spatial awareness, assisted autonomy, and dual immersion. Firstly, Viewer2Explorer's map-based interface improves spatial awareness, enabling more effective exploration compared to traditional timeline interface. Rather than focusing on browsing efficiency, in this research, we tried to enable viewers to easily navigate to desired locations within the video environment. With this methodology, we demonstrated the potential to broaden the manipulation capabilities within 360 video format. Secondly, we defined the experience provided by Viewer2Explorer as assisted autonomy, allowing viewers to navigate independently while staying engaged with visual components in the map interface. Lastly, we can say the experience Viewer2Explorer facilitated was a dual immersion. With Viewer2Explorer, viewers can alternate between different types of immersive experiences, which were provided by panoramic images and traditional 360-degree video tours. In user study, we could observe that this interface enabled viewers to manipulate the videographer's movements while also following them passively. In conclusion, this research highlights how a map-based interface can transform passive experience into active exploration journeys in 360 virtual exhibition. By expanding the experience from temporal to spatial, we could confirm that Viewer2Explorer enables viewers to explore the exhibition independently and autonomously. Thank you for watching.